Welcome back. This video adds a new interactive element to our Arduino project, a push button. You learn how to read the state of a button using a digital input pin and use it to control an LED. Let's start. You'll need a push button, the LED and resistor setup from our previous tutorial on pin 11, a couple of jumper wires and a 10 kilo ohm resistor. First, place the push button on the breadboard. Connect one side to digital pin 8 on your Arduino and the other to the Arduino 5V pin. We'll use a 10 kilo ohm pull down resistor to ensure a stable low signal when the button is not pressed. Connect the pull down resistor from the button side connected to pin 8 to the ground. And in this case, I'm sharing the ground that is already connected to the LED short pin, the cathode pin. Open your Arduino IDE and let's write the code. This Arduino sketch is designed to read the state of a push button connected to digital pin 8 and control an LED connected to digital pin 11 based on the button's state. It also sends messages to the serial monitor indicating whether the button is pressed. Here is how each part of the code works. This line declares an integer variable named button pin and initializes it with value 8, indicating that the push button is connected to digital pin 8 on the Arduino board. Similar to the button pin, this line declares an integer variable LED pin and assigns it the value 11, indicating that the LED is connected to digital pin 11. The setup function is called once when the Arduino is powered on or reset. It's used to initialize the pin modes and set up the serial communication. Pin mode, button pin and input, sets the button pin digital pin 8 as an input, ready to read the state of this button. Then you have pin mode LED output, which configures the LED on digital pin 11 as an output, allowing the Arduino to control the LED. And then you have serial begin 9600, which initializes serial communication at 9600 bits per second, enabling data to be sent to the serial monitor. The loop function contains the code that Arduino repeatedly executes, as you already know. It starts by reading the state of the button using digital read button pin, and then stores the result in the button state variable. High indicates that the button is pressed and low indicates that it's not pressed. This conditional block right here checks the button state. If the button state is high, then the LED is turned on using the digital write function and the string button pressed is printed to the serial monitor. If low, then the LED is turned off and button not pressed is displayed instead. Finally, a delay function pauses the loop for 100 milliseconds. This brief pause helps to debounce the button, which minimizes the effects of the physical vibrations or the electrical variations that can cause rapid on-off states to be read, and that reduces the frequency of messages sent to the serial monitor, making them more readable. Go ahead and upload this code to your Arduino. After the upload is complete, press the button. You should see the LED illuminate and the serial monitor to display button pressed. And when you release the button, then the LED will turn off and the message button not pressed will appear in the serial monitor. The button offers many user inputs and control possibilities. Aside from controlling an LED, you can use buttons to control servo motors positions, reset a countdown timer, or send out Morse code. You can connect multiple buttons to your Arduino to create a reaction game or educational tools like a quiz game. If you enjoyed this tutorial and are excited to see what else you can build, please hit the like button and subscribe to our channel. Your support encourages us to create content that helps you on your maker journey. Until next time, keep innovating.